Alright, so we already talked about describing numerical data, now we're going to talk about displaying. Alright, so a couple of ways you can do a dot plot, which we've already talked about. We've got stem and leaf plots, histograms, cumulative relative frequency plots, and box plots. So we're going to start off with the stem and leaf plot. Alright, so we can use this for univariate numerical data. Alright, how we construct it, we select one or more of the leading digits in the stem. List all possible stem values in a vertical column. Alright, we record the leaf for each observation besides each corresponding stem value. Indicate the units for stem and leaves in a key or legend. Now the key thing about the stem and leaf is you want to use this for small to moderate sized data. It does not work very well when you start having numbers that are in like the hundreds. Okay? Too much data messes up things and makes it kind of clunky. So this works very good for those small data sets that you don't have too much that you're going to work with. So let's look at an example. The following data are price per ounce for various brands different brands of dandruff shampoo at a local grocery store. We got 0.32, 0.21, 0.29, 0.54, 0.17, 0.28, 0.36, and 0.23. We want to create a stem and leaf display with this data. So we start with stem. So the stem that we're going to end up having is 1, 2, 3, 4, and 5. So if you notice here, we're using the tenths place for the stem. Okay? So when we're going through this, we can just go from the left to the right and just fill it in the spots. So the first one is 0.32. So we take the hundredths place and just put that one value in there for the leaf. So we got the 2. And then we got 21, so we put the 1 there. And then 9, 5, 4, so we go down to 5 and put the 4. 1, 7, we put a 7 up there. 2, 8, we go back to that one and put an 8. Notice again, it does not have to be in numerical order for this part in the leaf. Okay, you just keep on putting it whenever you get to the points with it. Okay, we're just looking at how many actual values are in that section. Then we got 36 and 2, 3. Alright, so here's our stem and leaf. We would need to describe the distribution on this. So, alright, looking at this one, the median price per ounce for dandruff shampoo is 0.285 with a range of 0.37. The distribution is positively skewed with an outlier of 0.54 cents. So, when we're looking at this, if you notice the picture, if we just kind of turn our head sideways on there, we got that 5-4 separated with there. So we have that outlier we see. Now, with that 5-4, that skews the data to the right. Alright, makes it more positively skewed. Okay, if it's skewed, we have to use the median for our center. Now the problem with this is that we have an even number of values. So the thing with this is if the numbers in the middle are not the same, we have to take those values and average them. So the values that are in the middle are 0.29 and 0.28. So we average that to 0.285. So again, if you have an even number, your average is going to be in the middle of that. Alright, now the problem with also stems and leaf plots is sometimes you end up having it where it shows not enough actual variance in the one. So let's look at this one. The Census Bureau projects the median age in 2030 for the 50 states in Washington DC. Stem and leaf plots are shown to the right. So the stems, the 10s, and the leaves are the 1s. Right? So when we're looking at this, alright, there's not that much of a shape figuring it out from there. So what you might have to do is split this up. So you notice again no shape, so we can't really see through the long list of leaves. So we're going to actually split this in order to better see the distribution. So to do that, we're going to have an L for the low, the values between 0 and 4, and an H for the high, the values between 5 and 9. Alright, notice we got the 2 high gives us that 9, 3 low. Notice how much of that data actually got taken out from that 3 above into that 3 high. So it gives us a lot better visualization of this one. And there's a bigger hump around the 3 high and the 4 low than it is where you have just those 2, 3, and the 4s together. You get a lot better representation of what the data actually shows. So we're going to look at this next one. Now we're talking about the following data for primary school age children who are enrolled for 19 countries in Northern Africa and 23 in Central Africa. Right. So with this one, instead of having all these ones with it, we're going to use the tens place for it. But the problem is, with the tens place, we have to use the ones place for the actual data. That leaves all those decimal points added into it. We don't want to use those decimal points because you want one value for each item in the leaf. So anything after that one value, you just cut off. You don't even worry about it. It doesn't stay relevant on the stem leaf plot. So for this one, we're going to truncate. This 4.6 becomes just 4. 34.4 will just become 4.4 instead of 4.3. All this stuff, basically, you just cut off the little extra parts. Alright, so that being said, notice that we had 2 different values here. So we have Northern Africa and the Central Africa. Alright, you can do a split stem and leaf. That way that you have one value is on one side, the other value is on the other side. And then you can compare the shapes of those 2 graphs based off of it. Again, you have that middle part that's your stem, but you have the leaves to the left and the leaves to the right. And you have those matching parts. Right. So, now we're going to look at comparing these 2 together. Right. So, the good thing about looking at this is the median percentage of high school or primary school age children enrolled in school is larger for countries in Northern Africa than Central Africa, but the ranges are the same. The distribution for countries in Northern Africa are strongly negatively skewed, but the distribution for countries in Central Africa is approximately symmetrical. Again, notice that you have that little bit of a tail on Northern Africa, but it kind of more of a symmetrical shape for Central Africa. So again, you describe the differences between the medians, the centers, the shape, and the spread whenever you're comparing different graphs like this.